Okay, we're back. We're going to talk about the empirical rule. That is also known as the 68, 95, 99.7 rule. And in a normal distribution, a specific percentage of scores will fall between any two z-score values that we want. However, a common set of z-score values that come up happen between these first integer values, between -1 and 1 standard deviations, or -2 and 2 standard deviations, or -3 and 3 standard deviations. And so we should memorize those. And those are the 68, 95, and 99.7%. Within 1 standard deviation, between -1 and 1 standard deviation, we have 68% of our data. You can look here at this pink shaded region. That looks like quite a bit. Within 2 standard deviations, or between -2 and 2 standard deviations, falls 95% of our data. We come out here, and we have quite a bit of the curve at this point. And then lastly, between -3 and 3 standard deviations, we have 99.7% of the data. And that really is almost the whole curve, with the exception of what we would determine as outliers beyond those 3 standard deviations. I said that between -1 and 1 standard deviations from the mean fall about 68%. Another way to say that is within 1, and you heard me say that. So within 1 standard deviation means 1 above or 1 below. And it's really important that you understand that we're not just talking about 1 in one direction. We can use the empirical rule to quickly calculate probabilities that scores will fall between whole number standard deviations. For example, the probability that a randomly selected value would fall between 1 and 2 standard deviations above the mean we can find by trying to find this shaded region using subtraction. If I take the entire region between 2 standard deviations and subtract the 68% of the middle, I'll be left with these regions that are right here on the ends, look like little wings of a plane or something. And if I divide by 2, I'll be left with this first region that would be just 13.5%. Another problem you might see is stated as using the empirical rule, what is the probability that z is between -2 and 3 standard deviations? So again, we look at the curve, we're going to be between -2 and 3. So there may be many ways that we can do this. Probably the easiest would be to start with the wider part. So within 3 standard deviations we have 99.7. And we subtract the narrower part, 95. And we're left with these extreme pieces out here. So we got about 4.7%. When we divide that by 2, we find that each one of these is 2.35. So I go back to my 95%. And then I add this one region here to get all the way to 3 standard deviations above the mean. So 95 plus 2.35 is 97.35, or a lot of times in this class we're going to write our probabilities as just decimal answers. So we're going to say 0.9735. Okay, here's a chart that you can use. I would put it in your notes. You can pause the video here and get it in your notes. And then I'll talk to you in a minute about some things to look out for. So if you finish copying the chart into your video, this has everything broken down into smaller segments. If you can use this as a reference, it's nice, but we still talk about it as the 68% between -1 and 1 standard deviations. We can split that in half because the graph is symmetric. So the area that's on this side is exactly the same as the area that's on this side of the mean. And the same thing happens between -1 and 2 or 1 and 2. Those are symmetric regions. Be warned, though, that you can't further split this up. And every year I've had people try to do a quick calculation where they say, well, I know this is 34% between 0 and 1, so between 0 and 1/2 they think might be half of that, and it isn't. you can clearly see if you look at the actual just size of the region that between 0 and 1/2 is much more than between 1/2 and 1. So it's not a linear division in that way. You can't just continue to break them down. That's why we have our handy dandy chart in the first place. If you get anything that's not an integer value standard deviation, we should be using the chart. Okay, so these are ideas for the empirical rule, and we're going to go on to the next video, which will include examples in the real world.